In 1940, the United States had fewer than 300 tanks that could barely scratch German armor. Yet within 2 years, a new weapon would roll off assembly lines at a rate of 1 every 30 minutes, the M4 Sherman, a tank built to save an army from disaster. The official story praises its reliability and numbers, but the dark truth about the Sherman tank starts with a rushed stopgap, desperate compromises, and battlefield consequences no one fully admitted at the time. Was this wartime legend a workhorse, a death trap, or something far more complicated? To understand how America's tank gamble changed the fate of World War II, we have to start with a crisis that no one saw coming. Before the United States ever sent a Sherman into battle, its tank force was on the verge of collapse. In 1940, Army records listed fewer than 300 tanks, most of them training models or lightly armored vehicles like the M1 combat car and the M2 light. Neither could stand up to German panzers, and neither could be built in numbers that mattered. The shock came with the German Blitzkrieg in France. Entire armies swept aside in weeks, not months. American planners realized their doctrine, tanks as slow-moving infantry support, was dangerously out of date. The army scrambled for answers, but the U.S. had no real tank factories, no mass production lines, and no time to experiment. With the clock ticking, the Ordnance Department approved a stopgap, the M3 Lee. It was a compromise born of desperation. American engineers couldn't fit a 75mm gun in a rotating turret yet, so they fixed it in a side-mounted casemate. A smaller 37mm gun sat in a turret above. The result was a tall, awkward machine with a 6-man crew crammed inside: commander, driver, gunner, loader, radio operator, and assistant driver. The M3 Lee was rushed through design and into production in 1941. Chrysler's new Detroit Arsenal tank plant started rolling out tanks before its roof was even finished. By early 1942, Lee tanks were being shipped straight from the assembly line to British forces in North Africa. They arrived just in time to replace the battered Crusaders and Matildas. The Lee's 75mm gun could finally take on German anti-tank positions and older panzers, but its high profile and limited traverse made it a target. Crews called it a mobile coffin, but it was the only option available. The Lee wasn't a solution. It was a stopgap to buy time while engineers scrambled for something better. The crisis had forced America's hand. The next tank would have to be built for a war. America was barely prepared to fight. U.S. engineers faced an urgent challenge in 1941. Design a tank that could be built fast, shipped anywhere, and survive the kind of mobile warfare the Germans had unleashed. The new tank needed to be agile, reliable, and, most importantly, simple to mass produce using American automotive methods. Every part, from the engine to the transmission, had to be standardized so that a broken-down Sherman in Tunisia could be repaired with spares shipped from Detroit or even from a different factory entirely. This meant strict limits on size and weight. The Sherman had to fit on standard railcars and into the cramped holds of Liberty ships, no more than about 33 tons, and no taller or wider than what U.S. cranes and bridges could handle. Engineers kept the hull compact and the suspension rugged, pulling from proven components wherever possible. The 5-man crew layout was chosen for efficiency and safety, with enough space for the commander, gunner, loader, driver, and assistant driver to work without tripping over each other. The main gun, a 75mm, was selected because it could be mounted in a fully rotating turret, giving the crew a massive advantage over the fixed-gun M3 Lee. Early on, they added a gyro stabilizer, a rare feature at the time, which let the Sherman fire with some accuracy while moving, a first for Allied tanks. Designers also insisted on parts interchangeability. A transmission made at Lima Locomotive Works would fit a Sherman built at Pressed Steel Car Company. This wasn't just about convenience, it was about keeping tanks in action no matter where they broke down. The Army approved the M4 in February 1942, and the blueprint went straight to the factories. What rolled out was a tank built for the realities of global war. Tough enough for the front, simple enough for the assembly line, and just light enough to cross a European bridge or ride a Pacific landing craft. The Sherman wasn't designed to win a beauty contest. It was designed to win a war by being everywhere it was needed, as soon as it was needed. In October 1942, nearly 300 Sherman tanks arrived in Egypt for the British Eighth Army, just as the Second Battle of El Alamein was about to begin. Crews found themselves facing Rommel's Afrika Korps in some of the harshest conditions of the war: blistering heat, endless dust, and supply lines stretching for hundreds of miles across open desert. Unlike the Crusader and M3 Grant, which had struggled with constant breakdowns, the Sherman quickly earned a reputation for mechanical dependability. Major General Barnes, sent to observe their debut, reported that British officers called it the best tank on the battlefield. The Sherman's automotive components handled the desert remarkably well. Tracks and wheels wore down fast in the sand, but the engines and transmissions rarely failed. Field workshops worked around the clock, swapping out worn parts and adding dust shields, extra stowage, and racks for water and fuel. Simple modifications that made a big difference in the desert. Most breakdowns could be fixed in hours, not days. Parts from one Sherman fit another, no matter which American factory it came from. This kept tanks rolling even after hard marches or heavy fighting. For crews used to the Crusader's fragile suspension and overheating engines, the Sherman felt like a leap forward. Instead of losing half their tanks to mechanical failures before a battle even started, British units could count on Shermans to be ready when the attack came. The 75mm gun, mounted in a fully rotating turret, let crews engage enemy positions without exposing the whole tank, and the early stabilizer gave them a fighting chance to hit targets while moving, something unheard of in rival tanks. The real threats came from mines and German 88mm anti-aircraft guns turned on their sides, not from the mechanical gremlins that had plagued earlier designs. Reliability in the desert wasn't just a technical detail, it meant more tanks in action, more often tipping the balance during El Alamein and building Allied confidence in the new American machine. At the height of the war, American factories delivered a Sherman every 30 minutes, more than 50,000 in total. This wasn't just about numbers, it was about keeping tanks in action and crews alive. The assembly line was only the beginning. Engineers and factory workers across 11 plants focused on more than speed. They kept a relentless eye on quality control. Each Sherman, no matter where it was built, shared the same parts. A transmission from Lima locomotive would fit into a tank from pressed steel. That kind of standardization meant a Sherman knocked out in France could be back on the line in days, not weeks, using whatever spares were on hand. But the real breakthrough came from listening to the crews. Early Shermans had a deadly flaw: ammunition racks in the sponsons right above the tracks with no armor. When enemy shells punched through, the tank often erupted in flames. In 1942 and 1943, nearly 70% of penetrated Shermans burned. Ordnance reports called it unacceptable. The fix, wet stowage, was simple but effective. Ammunition bins were moved to the floor and surrounded by water-filled jackets. If a shell hit, the fluid would douse the fire or slow it down long enough for the crew to escape. After this change, the burn rate fell below 20%. That single upgrade saved thousands of lives. Other improvements followed. Wider hatches, spring-loaded for quick escape, gave crews a fighting chance. Softer U.S. armor, unlike the brittle German plates, meant less shrapnel inside when hit, and the average fatalities per knocked-out Sherman dropped to about 1.3 crew members, lower than in some rival tanks. The myth of the Sherman as a death trap faded as the data rolled in. What mattered most was not just how many tanks rolled off the line, but how many crews made it home. In the summer of 1944, Sherman crews found themselves staring down the barrels of Panthers and Tigers, machines built for a different kind of war. The standard 75mm gun, once more than enough, now struggled to even scratch the front armor of a Panther. Even the upgraded 76mm M1, firing its best armor-piercing rounds, could only hope to punch through the Panther's glasses at point-blank range. Against the Tiger's 100mm hull, most shots bounced harmlessly unless fired from the flank. British engineers answered with the Firefly, squeezing a 17-pounder into the Sherman's turret. That gun could cut through a Tiger's side or even its mantlet at over 1,000 yards, but accuracy and ammo supply were constant worries. In battle, Sherman crews relied on teamwork. 3 or 4 tanks firing in rapid bursts, up to 20 rounds a minute with a skilled loader aiming for the tracks or gun mantlet, hoping to blind optics or force a hatch open. Outgunned, they learned to fight as a pack, moving fast, flanking, and trusting that volume of fire and coordination might tip the odds, if only for a moment. Sherman tanks didn't just fight, they adapted, again and again. When a Sherman was knocked out, recovery crews in M32 armored vehicles worked through the night, hauling damaged tanks off the line. About half the Shermans disabled in combat were repaired and sent back within days. This cycle kept Allied units supplied with armor even after heavy losses. The Sherman's standardized parts made repairs quick, whether the damage was from mines, shells, or engine failure. Meanwhile, engineers kept finding new jobs for the chassis. On D-Day, amphibious Sherman DD tanks rolled off landing craft and swam toward the beaches, giving infantry instant fire support. Other Shermans bridged rivers, cleared mines, or laid down smoke, all using the same basic platform. No matter the mission or the setback, the Sherman's design made sure there was always another tank ready to roll. By war's end, over 49,000 Sherman tanks had rolled off American production lines, an industrial feat unmatched by any other Allied tank. The Sherman's design was driven by urgent necessity, rapid deployment, mechanical reliability, and adaptability across theaters. Archival combat records confirm its 75mm gun outmatched early Axis armor but lagged behind late-war German tanks. Factory reports and after-action studies show that relocating ammunition to the floor and adopting wet stowage reduced catastrophic fires from nearly 70% to under 20%. Crew loss rates averaged 1.3 per destroyed Sherman, lower than many peers. Today, historians agree the Sherman was not invincible, but its numbers, dependability, and logistical reach proved decisive. The Sherman was not a mythic supertank, nor a mere death trap. It was a pragmatic solution that helped secure Allied victory.